Okay, so I'm getting a yes. All right, so I'm gonna go ahead and start. So welcome to a Tale of Two Powershells. I'm Fernando Tomlinson. Of course, this is BSidesGVL, and I just want to pause real quick and say thanks to the people that put this event on. This is amazing. This is my second year of being a part of it, and I look forward to many, many more of these. We need much more of these in our community of sorts to help the next generation. So I'll start by kind of introducing myself. I'm with the Department of Defense, namely the Army. Been with it for 18 years. Right now I do forensics and malware analysis. Previous to that, I was a technical director of an operations center in which we did cyber operations of all variants. I also am an adjunct professor where I teach Python and digital forensics. So I do that as an effort to kind of give back, if you will. I developed a number of red and blue team tools, all namely in PowerShell. You can tell that I really enjoyed the language. And I wrote a chapter in the PowerShell conference book, volume 2. And what's interesting about that book is we make no money from the proceeds. All proceeds go to underrepresented, underprivileged individuals so they can get a start in cybersecurity. And I think back to my initial start in cybersecurity, or really IT in general, and I felt like I fit that same mode. So I just want to do something for the next generation of sorts, and this was a great way to do it. There's a number of platforms that I kind of helped build, and then you see a number of sites where I'm at on the web. So if you want to connect or you've already been connecting, that's great. All right, so here's our agenda as we get into it. All right, we'll kind of highlight some blue uses of the language, some red uses of the language of sorts, and no matter what side of the fence you feel like you're on, it definitely could be of use to you. All right, so let's talk about the language. PowerShell was developed in 2006, originally called Monad. It was later renamed to PowerShell. The language itself is implemented as an engine. That could be from the perspective of command line or a GUI variant. And generally when we think of PowerShell, we think of PowerShell exe, PowerShell underscore ISE, but really that's the hosting engine. And the actual PowerShell language itself is really a compiled .NET executable that is system.management.automation.dll of sorts. So as long as we can take that DLL and apply it to any other binary or any other process, we can leverage PowerShell and the commands that go with it. So it's always interesting when organizations are trying to limit the use of PowerShell, and the first thing they want to do is block the executable when really we should be concentrating on that DLL of sorts. So it's an interactive command shell. So very useful scripting language, much like a simplified C#, if you're familiar with the language. It also has a built-in capability for remoting, which is PowerShell remoting. It gives us the ability to do it through HTTP, HTTPS. So we have a SSH-like capability within the language, which also speaks to what makes it great. As I mentioned before, PowerShell itself is nothing more than compiled .NET. So because it is that, it gives us access to the .NET framework, which then further just opens up our abilities within the language. And it is full of objects. Everything we do in PowerShell is an object. So if we found ourselves in, let's say, a traditional command shell or bash, and we're trying to slice and dice and get a particular piece of data, we may find ourselves, specifically from bash, we may find ourselves setting, awking, and cutting, and then, oh man, what if we're off a little bit? We find ourselves kind of doing it all over again. But with PowerShell, we can select the very property that we care about, and it will return that because everything is an object for us. Now, the functionalities are largely broken down into 4 aspects. We have commandlets, which are pre-compiled .NET items that allow us to do certain functionality within the language. We have functions that we build ourselves and or come with the language, reusable chunks of code. We can then turn those into individual scripts that we can leverage as need be. And then guess what? We can still utilize the native commands that are already inherent to the operating system. So we don't really lose out by utilizing PowerShell. We really just gain more. So from a blue team perspective, right off the bat, what makes it great? Well, when we look at Windows 7 in 2008 R2 and above, it's already there. I don't know about you, but whenever I go to a get together at a friend's house, I like being able to come over and they say, Fernando, don't worry about bringing anything, just bring yourself. And when we look at jumping on specifically a Windows machine, Win 7 and above, we find ourselves with PowerShell already there. So from a blue team perspective, we're not adding anything else to that operating system. We're just leveraging what's there. The same could be said to the Windows APIs. All right, PowerShell has the ability to interact with them so we can take advantage of those pre-compiled things. We have the ability to just import DLLs and then utilize those functions that are made available. We can encrypt that traffic. So I spoke briefly about PowerShell remoting, right? Where we could either have an actual certificate published or we can have a self-signed certificate, but we have that SSH-like capability where we can do one-to-one machine or we can do one-to-many. And this is all inherent to the operating system, or rather, excuse me, the language itself. Now, it also gives us the ability to monitor and track people trying to abuse it. This has gotten better over the years, namely once we really got into like PowerShell version 5. Giving us the ability to truly track what a person's doing. Now, because we're in a cat and mouse type field, as we as blue teamers gained another way to track a red teamer's actions, they have certainly increased their tactics as well and started trying to bypass it. But it has made it much more difficult for them than what it was in the past of sorts. And guess what? From a blue team perspective, if your organization can't afford the latest EDR, then we can make something within PowerShell, either from an agent perspective or agentless. And I'll talk about one of the agentless variants that I end up making to kind of satisfy this thing. Now, from a red team perspective, guess what? The first 3 bullets are the same. As a red teamer, if I don't have to bring anything, that's even better. If I can blend in and live off the land, why wouldn't I do that? Especially in a large organization where they may already struggle with what normacy is in that arena. Again, same thing with the APIs. And then if I can encrypt my traffic, absolutely, I want to do that. I want to make it much more difficult for the defender. Now, we have the ability to bypass or really avoid detections, as I kind of talked about briefly with the new advances with PowerShell v5 and newer. We, from a red team perspective, can still bypass and navigate our way through them, but it is much more difficult. Now, if we're lucky enough, we find ourselves in an arena where somebody's using a legacy version of PowerShell, specifically like PowerShell version 2, which has no security features built in. And then it just makes it much more difficult for that blue team to be able to find us later on, right? So why would they be running the old stuff? Well, maybe it's due to the infrastructure, maybe it's due to lack of skill set or knowledge or understanding of how to actually upgrade, right? And even if organizations are on the latest and greatest version of PowerShell, they may not even have it optimally configured to be able to highlight a number of things that we would be able to do. Now, one of the things that are largely great that I thoroughly enjoy is the ability to do things without touching disk, right? Arguably, a red teamer is either going to execute things that are touching disk or they're going to execute in the context of memory. If somebody's touching disk, should be much more easier in theory to find. When we get into executing purely in memory, now I kind of need something to lead me to that system in order for me to focus on the memory aspect. So with PowerShell being able to execute fully in memory, when leveraged in that manner, that is great. And because it is a true scripting language, it starts to make signatures really, really difficult, right? It's not like a particular compiled binary of sorts where it's kind of static in nature unless you recompile it. It's truly a cat and mouse thing with this script because you have the ability to continuously reshape the arrangement of the data and really how it's being called upon. So we really start to just briefly touch some of the good and bad of it all, if you will, or really what makes it great for either side. And when you look at this and really listen to it, you're like, huh, well, maybe that's useful for the other side or what have you. And that's really true. And when we look at it, I kind of see it like this, where there's a large subset of what PowerShell can do that's useful for not just one side. It's really a triad of sorts that bleeds into other areas. It's really the focus in what you're trying to do and leveraging what you're trying to do that really depicts what side you're doing it from. So it's not a one size fits all type thing. Now, outside of red team, blue team, and just system administrators, PowerShell also has the ability to be a little bit more granular. So for example, this young man ended up using some PowerShell so he can control his Tesla, right? I'm all about that. Had the ability to leverage the language, leverage a subset of APIs and whatever connection accesses he has into his system, and he's using PowerShell to control his Tesla. That is awesome. Now, that may not be the only case or use cases of PowerShell. It's really an endless possibility of sorts. And no, this is not a joke, right? Literally, you could Google that and you'll be able to see his GitHub of sorts. And if I had a Tesla, I would test it. Unfortunately, I don't have one. So I had to take his word that it actually works the way he says it does. So from a blue team perspective, we'll start to just kind of highlight a couple of things that we can do with it of sorts. And then we'll transition over to the red things that we can do. Again, not all inclusive, varying levels of degrees, if you will, but nonetheless, giving some exposure to it. So when we look at just hashing, period, right? This is something we typically do when we're hunting or we have some type of indicator of compromise, whether we're using some other framework like Yara or some other reputation-based thing. Hashes could arguably be part of how we do things. So from the perspective of hashing, we have an input, whether it's some form of binary file or what have you. We have a process in which it undergoes the algorithm function, and then we get this one-way computation that comes out and gives us high confidence that when we see this, it is that system. Now, there are collisions, but again, based upon the algorithm in which we're doing, those are a little bit far and few. But when we get these hashes and we want to be able to utilize them to look at systems or look at items, we can utilize some PowerShell here. So there's a commandlet, get file hash, and we can specify the individual file, binary, whatever it is. And by default, it's going to come back as SHA-256. But as you can see in the second example, we can give it the parameter algorithm, and then we can specify what algorithm we would want to actually do it in. So MD5, SHA-1, SHA-256, triple DES, is that, if that's your thing, right? Now, when it comes to actually doing more than one file, well, we have a couple options to do it. One way we can do it is we can get a listing of the directory, and then we could pipe it to the next command. So as you recall, I talked about PowerShell being object oriented. So when we get a listing of our directory, those are objects. And then when we utilize pipe, we're sending all those objects to another command for them to actually do something with it. And in that case, we're able to get a directory of files and actually return hashes against them. Now, when we look at, cool, I want to do this a little bit larger in scale, how would I go about doing that? Well, you probably want to start with a list of well-known hashes. NSRL publishes those things once a quarter. That's a good starting point. Or if you have some other type of reputation-based subscription service that you can pull them from, that's great too. Now, you would probably want to do the whole disk. Depending on your infrastructure, your architecture, that may be very taxing and not something that you want to tackle. Instead, a compromise would be, well, let's just hash every process that runs, and then if it's unique, add it to our list. If it's something we've already seen, just pull from our list, and then we continuously build like that. That becomes to be a little less processor intensive. So from a PowerShell perspective, we can utilize the 8 or 9 lines that we have in that red box there. So essentially, we're gonna retrieve every process, we're gonna sort them based upon unique, and then we're gonna loop through each one of them, and we're gonna get the file hash. There are some protected processes that my privilege level or the privilege level in which you're executing may not have access to. So I wanna be able to highlight those, and that's where in our if-else statement, we see that we're gonna send it to a log file. So again, we're being a little bit directed in now how we're doing this as opposed to doing the whole disk. Again, my architecture really depicts which method I could actually use. Now, once I have these, I still need to actually validate that these are good or not. Maybe I have some in-house subscription service. Maybe I want to send it out somewhere. So if you want to send it out somewhere, one of those things is virus total, wrong, right, and different. right? And VirusTotal has a free API, so we can do this from the command line perspective. Now, there are the limitations. The limitations: 4 requests per minute, 5,700 and some change requests a day, and we see the monthly quota. So being able to use some PowerShell here, we're able to grab the hashes that we have already seen. If we haven't ran those against VirusTotal, then we're going to send them out to VirusTotal. No need for us to send the same, SVC host with the same hash out to VirusTotal 500 times, right? And because we know we can do 4 a minute, automatically go ahead and split it up into every 15 seconds submitting one, right? So we see in this case, I'm submitting 2 hashes. The estimated runtime is 30 seconds. And it doesn't matter if it's MD5, SHA, whatever, right, of sorts. And I'm returning that data back out. Now, when we submit this to VirusTotal, we get roughly 50 AVs or so that come back and really highlight to us whether they believe it's malicious or they haven't seen it yet. Now, just because they don't render it malicious doesn't mean that it's not, but we take everything we have with a grain of salt as far as a indication. Now, when it comes back to us, it comes back to us in an object with a number of properties. And we see that first column, which is really a property, we see the AV. The second column, we see what version of the AV. That third column, which is another property, we see whether it returned true or false. False being that it doesn't think that it's malicious, true being that it deems it malicious. And then that fourth column, we start to see what they know that malware family or variant is, right? And that's going to vary between AVs, right? We see what the actual engine is, and we see the actual hash. Now, from that perspective, I am now able to kind of quickly see, like, hey, this thing's running in my environment. Out of 50 AVs, a couple of them think it's bad. Let me put this in a bucket where I now go and pull that binary and or do a little bit more analysis on it. And then largely, if I start to group my processes across my infrastructure or my architecture, how many other instances of this binary is actually running, right? And where applicable, we start to whitelist it. So that becomes a tactic that we can use utilizing straight PowerShell across our infrastructure. Now, something else we can do with PowerShell, we can get processes, we can get net TCP connections, which is essentially our net stat, right? And our processes is essentially our task list. And when we look at that, we get something like this. The top figure shows the get process and how it returns. The bottom one shows the net TCP connection and how it returns. And as an analyst, I may find myself looking at a net stat, seeing something with an established connection, seeing a binary or a PID tied to it, and now I have to transition back to my processes and then get a little bit more information there. Like, okay, cool. What time did this kick off? What kicked it off? Like, what's the parent? Were there any command line arguments with it? And as an analyst, I get a little confused sometimes, right? Was that PID 1920 or was that 9120, right? So from the perspective of putting it together, I started thinking about this, right? We got Reese's Cups, we got Reese's Pieces. Somebody decided to put it together, and I tell you, that genius, right? So I ended up taking that same concept and coming up with Get-Verbose Process. And really what this starts to do is reduce human oversight, gives us a clearer picture from an analyst perspective. And then, oh, by the way, if you have some other thing that you'd like to import this data into, we can get it out as a CSV, XML, and make it already in a parsable manner. Because again, we're talking about objects here, so we have properties that we can tag those fields with. And when we get that back, we have something like this. Now, this is actually showing 2 individual items, if you will. So now right up front for each one, I get the IPs associated with it in the ports. I also get whatever the processes is, or are rather, and the process ID along with any command line arguments. We also get the hash associated with the item, right? We get the same thing for the parent as well. So from an analyst perspective, I'm starting to take some of my human nature or possible human oversight out of it, and I'm starting to get this in one clear thing. And oh, by the way, if I'm going to import this into some log aggregation server, now I've already manipulated the data and made it a little bit more readable, as opposed to have to try to pull it back together later on. From a forensics standpoint, if there's anybody out there doing dead box forensics, largely speaking, regardless of the case, we find ourselves getting a large subset of the same data every time, and then we start branching off based upon whatever knowledge we have about the hard drive or the case in which we're working. So came up with automated profiler. This is going to parse the drive looking for typical data that we're looking for. I've only really worked with 500 gigs or so, and in doing so, it's about 4 or 5 minutes to do that. And when we get that back, we get that back as a report. So now when we're talking about initial triage, I'm able to get this done fairly quickly, get some huge data points about the drive and characterization, give that to my management to allow them to feed it to whoever they need to for the time being, which allows me to then go a little bit deeper, right? All too many times we got this hot case going on and somebody's over you like, did you find anything yet? Did you find anything? What's taking so long? Well, cool. Let me give you this initial assessment very quickly, right? In an automated fashion. And then I'm gonna go a little bit deeper based upon whatever the case is. So here's some items that we're retrieving. Again, largely things that we're gonna do every time from a perspective of dead box forensics. And how do we end up executing this? Well, whatever you use to mount the drive, whether it's FTK or something else, right? Doesn't matter to automated profiler. As long as the drive is mounted, you run the script, you're gonna analyze the results. Again, it's gonna come out as a flat text file, all right? And I say relax, but largely you're gonna go back and do some deep dive forensics, right? But because you're doing this in such a quick amount of time, you could go and do some yoga or whatever the case before going back to do the next part of it. So the UI of sorts is nothing special, but it gives us percentage, right? Because it could take a little bit of a minute outside of that 500 gigs, depending on how big it is. And then when we get it back, we see it's going to be a flat text file of sorts. And again, I'm looking for the same generic data that I look for every time, right? I want to automate the boring stuff so I can get to the one-off or the deep dive stuff. An automated profiler allows us to do that. Now, when we look at DNS, right? DNS and really sinkholing becomes a mitigation technique that we could use when we have beaconing domains or infrastructure that's beaconing out to malicious domains, right? So let's explain the DNS process, largely speaking. We have a user, starting in the bottom left, we have a user that navigates to Google, right? And the first thing it's gonna do is it's gonna search their local host file, and then if needed, it's gonna check their local DNS, and then if needed, it's gonna query their DNS server that's supplied. And then if needed, that DNS server will check its cache. If needed, that DNS server will see if it's authoritative, and then it will utilize forwarder root hints, however it's configured. So when we look at how do we implement some type of mitigation when we have systems beaconing out to domains, there's really two spots that we can do that. And we see those areas which are now highlighted in teal. We could either affect the local host file because we see in that process that it checks the host file. But when I have a domain worth of stuff, I'm not going to go out there and do this on every system. Maybe one-offs, yes. Well, how do I do it from a larger scale? Well, then I'm going to do it at my DNS server. And what I'm going to do is I'm going to create authoritative records to say whatever that domain is, I'm authoritative for. And when I'm returning the IP back to the system that's looking for the IP, I'm going to say that it's going to be quad zeros, right? Essentially rendering that as a sinkhole domain. Now, if that doesn't make sense, let's look at this mural here, or this little picture. We have a person that's starting on the left in a car, which we don't see because he's off screen, and he's trying to get to the other side where those buildings are at. There's a gigantic hole in the ground. Essentially, he can't get to the other side because that hole, sinkhole, is preventing him to do it. Now, let's negate the fact there's a little bit on the side in which he could drive around. Largely speaking, that's what we're doing when we sinkhole a domain. So from the perspective of this, we would execute Invoke-SinkholeDomain, right? It's going to download a blacklist of domain if we have it configured for that, or we could input one-off domains that we want to blacklist. It's going to create forward lookup zones for those domains, and we're going to create a pointer record that's going to be pointed at quad zeros. And again, this is all automated in fashion. And we start to see those domains or those records out to the side. And then if we look in the middle there, we see our A records pointing back to quad zeros. And that's what we give back to the system, and the system doesn't make it there. Now, this is a method and technique we can use as part of the overall mitigation strategy, especially when we start looking at we should be doing things from a defense in depth perspective. But again, We're utilizing PowerShell to be able to do that. PowerShell. Event logs, right? Event logs and PowerShell, we have two different ways to parse those. Get win event, get event log. Get event log is really XP 2003. It's deprecated, but it still works for things like security, application, system logs. Get win event is more modern in nature. So we get the event tracing logs and a number of other things. Both of them allow us to do them local and remotely. Also, get win event allows us to take exported logs and import them in and parse them. This is largely important too, right? Because I could be struggling with a system in one location. I could export those logs, give them to you. You could utilize some PowerShell and parse them. Or we could write parsers in PowerShell and then run it against our log set, right? This is interesting. So looking at event logs, we largely get something like this right off the bat. I'm looking at security log. We're looking at 4688. That's going to be process creation. That's an important log in my opinion. It is not enabled by default. But what is this screen really telling me? It's telling me a time in which a process started. And essentially that's it, right? So if I want to open that up and go a little bit deeper, well, I can utilize select object. And I only did that on one, but I selected every property that's available. And this is returning to me in a format list. Now, we see properties like message, version, level, right? The meat and potatoes of what I really am looking for is in the message field, But guess what? There's not a clear out-the-box method for me to just select those very things in the message field, right? So stuff like the account name, the process name, the parent process, those are things that I would want. So how do we do that? Well, there's another property called properties in which we can go deeper and parse that message field. This is one of those things that we do it once and then we use it many times. We would need to do this with every log that we're curious or interested in. So once I'm utilizing the properties within the property field, I can now pull out the very things that I care about. So we see the process, the command line, the account, the creator. We see all those things that were normally in the message field that I've now pulled out. Now, I've renamed them to make them make a little bit more sense for me. But guess what? Once I built it once, I can take any event log with 4688 and I can run it through that parser and it will present that data for me, right? I built it once, I use it many times. And now I see things that may pop out to me. In this case, a guy using Netcat going out to quad fours, and what kicked it off? Well, it was a command prompt, right? Maybe benign, maybe not, but now I'm trying to make it a little bit clearer for me as an analyst, right? And we're doing this again in PowerShell. Now, there's also out grid view. Out grid view is an Excel-like view within PowerShell, right? And if we don't care for that, we can also export them as CSV, XML, and then put it in our log aggregation system of choice. So I had mentioned having an agent or EDR. End up coming up with PowerShell Rapid Response. Enterprise-wide capability enables me to find some anomalies. Right now we're doing 20 items of interest. It's extendable in a sense of modules rather. So it's modular that somebody else can make a module and just import it into the framework. It utilizes the pull capability. So it's not going to be a near real-time thing. It's going to be a matter of how often do I exercise it where I go out there and pull. So there is a chance I may miss something. It retrieves data, puts it in a SQL database. So now I can look across historical data and I'm not only confined to that one individual pull. It utilizes a network logon, so I don't have to worry about spraying creds all over the place and somebody trying to take advantage of it with mini-cats. So here are those things we talked about that it grabs right out the gate. And again, modules can be built and just added to this framework. All right, so let's demo this. don't even know what it's called now. Oh, just straight up PoSh2. All right, so what that's thinking, this is another machine that I have. That's when I'm gonna run it against. All right, so once we get it running, we have the ability to utilize systems within a domain, just auto pull. We can import a list based upon a file. We can feed it CIDR. We can do the local system, or we can do IPs individually. I'm gonna do individually, and that system, that other one, it's gonna be .200, all right? So if I gave it a larger subset of systems, it's going to be multi-threaded in the sense that it's going to go out and get this information, come back to a general collection point, and then get added into the actual files in which I'll then go back and look at if necessary. So while it's going out and doing that, let's look at the structure. So as the data comes back, the dates are a folder is created for each date and time that I actually ran it, right? So you can call those actual pulls. So today, this is the one that we're running now, and these are starting to come in. Again, we're only doing it against one machine, but from a historical perspective, I can go back and grab a pull from a specific day. And if I don't want to do the CSV thing, well, it also gets added to a SQL database. Right? And within that database, I can go back and I can link it to some other front end of sorts, or I can come in here and just look at it from a GUI perspective, or do SQL commands from a command line perspective. But I have a few options in how I actually parse and really look at that data. Right? And once it comes back, like I said, it goes to a landing zone, and then it goes into the next part where it starts to add things to the actual SQL database of sorts. And at that point, it's no longer connected to another machine. Right? But the fact that we have them as CSVs allows us to really get as granular with them as we choose, right? So we're not just limited, well, it only comes back in this format, so I'm stuck looking at it there, right? No, we can really do a little bit more with it from that perspective. So that's gonna be PoSh2. Again, we can do straight up pull from a domain that I'm already a part of. I can feed it a text file full of IPs. I can do an individual IP. I got options. All right, so Invoke-Suspend Process. This essentially attaches a debugger to a process. So let's say I'm trying to better understand a process running in my environment. Maybe you're trying to do some reverse engineering. We can attach a bugger to a process to suspend it. This allows us to maybe dump the process. Maybe it starts real quick, starts another process, injects itself, and then terminates before we can do anything with it. Well, we can go ahead and suspend that process, so then we can dump it and get a little bit more with it. Or if it's one of those things where anytime we terminate the process, it has some type of evasion in which it monitors for that and then starts or spawns a new process of itself. Well, rather than continuously fight that game while we try to figure out what's going on, let's just suspend it, right? So then we're still getting after some mitigation of sorts while we try to better understand it. Now, let's demo what this looks like. All right, so from this perspective, I'm gonna have this binary run, and largely only thing it's going to do is it's going to spit out whatever number and then say it's beaconing home. It's benign in nature. All right, and I'm going to stop this because it's starting to import. All right, so we're going to go in. Actually, we got to get the process or the PID. So we'll come in, we'll get the PID. And this PID is 8656. So then I'll come in, I'll run this code. I just need to feed it the ID, 8656. It's gonna attach a debugger. Now, I need to have SC debug privileges, right, to be able to do this. But we see now that I've attached a debugger to that process, it's in a suspended state, and off to the left, we no longer have it saying it's beaconing home. It is stopped. Now, we've dumped the process, we've done whatever analysis we want to do, or we're at the next point where we want to better understand it. We can go ahead and we could resume it. So essentially, we're going to resume process. We're going to feed it whatever ID, and then we're going to go in and remove that debugger. And we see off to the left, it continues with beaconing home, if you will. All right. So that's actually Invoke-Suspend Process. Again, just really highlighting how we can do some analysis, reverse engineering, better understanding binaries of sorts. If you've ever been on a Linux machine or you have a forward-facing internet-capable machine, you might have installed Fail2 Ban. Well, I wanted to do something like this for a Windows perspective, and everything that I seen didn't really get after everything I wanted to. So I ended up making this. So we have it configurable based upon thresholds or how long we want it to actually be timed out. The blocks actually go to the Windows event log and the firewall, but also a SQL database. And then we have the ability, if need be, to remove all IPs in a very quick manner. So we'll go through, we'll demo this. So I'm going to do Invoke-Fail2 Ban. I'll come here. I can right out the gate start monitoring. I can list banned IPs and their statuses. I can list all whitelisted IPs, or if I'm in a disarray of my network, I can just unban them all very quickly. I'm going to come in and I'm going to start monitoring. And let's get rid of my beacon thing over here. I'm going to come in, I'm going to start monitoring, and it says, hey, your IPs will be whitelisted. Do you want to add any more? No, I don't want to add any more. All right, so it comes through and it tells me all the IPs associated with my current system. So I'm going to let it go. I have it running rather aggressively, where it checks every 20 seconds for a system, and I have it, I think, 4 failed logons or 4 attempts of sorts. So I'm going to come in and I'm going to do this a couple of times to try to get for it to catch here. All right, so I have it at 20 seconds. So at 20 seconds, it'll come back and say it's monitoring still, or whatever the case. And if I have caught it within the specific time frame, it will go ahead and block or invoke that ban on that system, which we see it has, right? It is ban 155.200. I can come in here in my my firewall, and when I refresh, here in a second, I should be able to see that's the way. All right, so there's that ban. And because I have it 20 seconds to only ban it, it deleted it. So if I refresh again, it will be gone. Now, I needed it to actually log something. So what I did was I actually wrote it to the event log as well. So we see the provider is PS Fail2 Ban. We have an event ID that I just made up. And then I have pertinent information that it was blocked. Here's when it expired. Here was the firewall rule associated with it. And now, if I needed to, I could take that SQL database, pipe it somewhere else to a front end, or I can just take the event log and pipe that straight to my log aggregation server. And when we look at it from the perspective of listing our banned IPs, it will tell me that I only had one that I've ever banned since the declaration or creation of that SQL database. I see that IP, I see when it was added, I see when it expired, and it tells me it was removed. So it will continuously build onto that SQL database of sorts, each coming up with their own unique ban ID. So that's Invoke-Fail2 Ban. Again, Windows perspective, PowerShell, public-facing systems that are just getting beat up all day, every day. All right, and really, I missed this aspect of it. Why is this a thing? Well, public facing, I have somebody out there that's trying to access it all day, and they're probably out there just brute forcing. So the red signifies failed logons, and then they get to the end,
we got a green log on, meaning that it was successful. Well, with Invoke-Fail2 Ban, I say, hey, if I get 3 failed logon or 3 authentication attempts within this period of time, ban that IP for this period of time. Maybe it's 3 months, maybe it's 4 months, or whatever the case. So at 3 failed logons within that period of time, Invoke-Fail2 Ban kicked in, and now that machine is not able to talk to my machine anymore. So we can lessen that, but we also start to gain intel as far as who's out there trying to do what to us. All right, so cool. So that really highlighted the blue aspect of some of the things we can do with PowerShell. Let's get into the red aspect fairly quickly here. All right, so we have data storage. And when we look at data storage, this is typically like stagers. So how would that work? Well, we would take the data, that binary, we would convert it to bytes, convert it to base 64, and store it. Or maybe we do hex and then base 64 or whatever. Or you just go through that process a number of times. Well, if we're talking about storing it, where will we store it? Well, really anywhere that we can put data on a Windows machine, and we could also retrieve it. The registry, Active Directory if we got access there, event logs, alternate data streams, GPOs, you name it, right? And we're talking about stage 2, if you will, right? Like I gain access, I then have it stored somewhere, and then on some predetermined time, I have myself or the system reach out, grab this one-line stager that probably is nothing more than an IP address and a file to download, and then execute. Now, if somebody catches this stager, what do I lose? Maybe a domain, maybe an IP address, but that's it, right? It's not like I've already got on the system and just brought the whole tool set at one time. I got on the system, surveyed it, and now we're going to the next aspect of it. Well, Active Directory. From an enterprise perspective, these are containers largely configured in organizational units, users, computers, groups, all of these objects. This is the nucleus of sorts when we talk about authentication for a Windows environment, enterprise. What's interesting is that these objects have properties, and the properties are in the sum of roughly 50 or so for every user. Some of them are shown by default when we're in Active Directory users and computers. Others we have to pull out because they're not by default. Now, domain users by default can read these properties. It requires elevated rights to alter them. So from the perspective of utilizing PowerShell, there's a commandlet get AD user within the Active Directory module that allows us to interact with Active Directory. I like to utilize the division property to be able to put my code in for storage. Why? Because it's not shown by default, and largely organizations don't use it, nor do they know it even exists. And if it's not the division property, there's also probably easily 10 or so other properties that are useful as well. What's interesting about the division property is that it starts to give us, or each property gives us a set amount of characters that we can put in. So if I'm trying to do an actual binary for whatever reason, well, maybe I don't want to do the employee number property. Maybe I want to stick to division or something else. If I'm trying to do a short one, well, maybe employee number. But nonetheless, it's in a place in which you have to be looking to actually see it. Now, we can do the same thing with the registry. We know the registry is a mounting of stuff and really data within the Windows machine. From this perspective, we can create a key value and then put in our base 64 code as a value data. Now, if an admin comes across this and they see it, they're probably going to be like, wow, that data looks weird. What is this? So in order for us to hide this a little bit more, right, we notice right above my base 64 code, there's a value not set. What we can do is, as we implement or really store this data, we could pad it with a subset of characters. And what I'm doing is putting value not set in the data field, and then I'm padding it 160 no characters, and then I'm putting my base 64 there. So from the aspect of an admin who just happens to see this, they may not think twice about it. Oh, it's a key. A value, and there's no value set. All right, I'll keep going. Now, if they double click and interact with that value, they'll see it. But again, in a mountain of keys with no insight into key creation or alteration, this is a good thing for me. I can let it sit there forever. This becomes a good space for persistence as well. Now, from the perspective of port scanning, we can do that with PowerShell. I don't have to use Nmap or some other type thing. All right, this allows me to massage a port, see if it's actually open. From PowerShell v5 and newer, we have Get-Net connection. This is going to do a full scan with an auto close. It also pings the target beforehand, so I don't really care for it. It's a little bit slower. We could utilize the Net Sockets client class from .NET. This works with version 2 or newer because we have the .NET framework 3.5. This is going to do a full scan, but it leaves it open, so we actually need to go in there and close it when we're done with it. We can also do some banner grabs. All right, so this is great because maybe I don't have Telnet on my machine. You know, that becomes a method in which I use to do some banner grabs or Nmap or whatever the case. I can just take PowerShell that's already there and start banner grabbing across. Right? And as somebody who's doing defense, what does that look like? Would you be even able to tell? Does that look benign in nature? Right? I don't know. That's something that's of interest because, again, we're able to do so much with PowerShell. So let's look at what this looks like for us. All right, so when we look at the port scan one, I'm talking like 26 lines, right? And I could probably get this down a little bit more. And really it's 18 lines because I got some parameter stuff up here of sorts. So I'm gonna do invoke port scan. I'm gonna specify the system. Now I can do more than one system, but I'm only doing one right now. And I'm not gonna do all 65,000 UDP and TCP ports. I'm gonna be very targeted on what I'm looking for. And I'm gonna do 22, 80, 135, 443, 445, right? And we're specifically looking for those things. Now, this is going to take a quick minute, and we see that the first property is our IP. We see the port, and we see if it was successful or not. So on that system that I was just scanning, we see all those ports are open except 443. Now, if I had no indication, because I get 80 and 445 back, I might start to think, I'm sorry, not 80, 135 and 445 back, I might start to think that this is a Windows machine, right? As I'm taking notes and really trying to characterize it. Now, from a banner grab perspective, right, a little bit more, we're talking roughly 60 lines, but I'm gonna do the same ones, right? And this time I'm gonna see if I can get a banner on any of those services so I can further characterize the system. All right, so we got two back. Right, we got the TTL as well. So if I'm interested in trying to understand TTL for Windows versus a Nix box, maybe I start to use that to also strengthen my case. But nonetheless, I see on 22, we got SSH 2.0, Flow SSH, Bitvise SSH, Win SSHD. Now that starts to tell me this is a Windows machine. If I was unfamiliar with that, I'd go out and look on the web and look at that software to see if there's different variants of it. Now, if that's not enough for me, Port 80 actually returned a banner for me as well. And I get Microsoft IIS and I see the version, right? So I'm utilizing PowerShell to be able to do this, right? Nothing special, just whatever is built in to be able to do this, and very targeted of sorts. Living off the land, so this is great. All right, and then we have a simple HTTP server. So if you're coming from a Nix background or typically do your thing on Nix from a red team perspective, you know, we have the Python simple HTTP server, ended up coming up with the PowerShell variant of it as well. So very little configuration. We can stand up very quickly, small amount of code of sorts. If we want to HTTPS it, we can. We can bring our own certificate, self-signed certificate, whatever. We can customize the listening port. If it's not a well-known port, right? If it's an ephemeral port, we don't need elevated rights to be able to do that, right? So me as a regular user, I can stand this up as long as I have access to the classes that I'm actually using of sorts, right? So this is a method where maybe I got to a place and now I'm trying to bring something else from my toolkit or some other type of capability of sorts, and I can utilize this very quick, dirty, but useful server. All right, so I'll come over to my server machine. I'm gonna host on all IPs of this machine, but on 9,000, and we see that we're talking roughly 86 lines of code. And by default, I'm going to host data that's going to be on my desktop of this machine. I'll come back over here, and now we'll go out to that machine on 9,000, right? And I see what's on the desktop. As I go into the folders of sorts, I could interact with these things, or if I wanted to, I could just download it. Right? So we see I just downloaded this netcat or what have you from this other machine. And then when I'm done with that machine, i.e. that server, I could do something like get job, right? And then I could shut that server down. Very hasty. I stand it up, I get what I need, I tear it right back down, and I keep going with my mission or my objective. All right, so this brings us to the summary. All right, PowerShell is a very powerful language built in, very specific to system administrators, but useful to a lot of other variants and people. We see what we can do from a blue team perspective, just barely scratch the surface. We see what we can do from a red team perspective, again, just barely scratch the surface. So if you think PowerShell is something that you want to get a little bit more into, then I want to give you something to put in your toolkit, right? Kind of like one of those infomercials where it's like, well, wait, you know, there's more, right? I'm going to sweeten the deal for you. Me and two other people ended up coming up with Under the Wire. If you've heard of Over the Wire, Under the Wire is a play on those words, but specific to Windows, specifically to PowerShell. So what we do is allow you to SSH into our game servers. We provide you with a subset of objectives. And from an interactive perspective, you will learn the language because we're giving you challenges. Call it exploratory learning of sorts. There's 75 challenges that are there. To date, we've had over 140,000 unique people play from roughly 84 of the 193 countries, right? So again, it is free. We make nothing off of it. It is to help people get comfortable with the language and learn it. Now, once you get over Under the Wire, because we're focused on basic core aspects of the language, and you want to start using the language from a true red team or blue team perspective, well, then I implore you to use PoSh. Developed this in 2017. There's 90 challenges or so, and there's an actual virtual machine that you would download in that share environment. It is riddled with artifacts of sorts. So I may present you a question telling you from a blue team perspective, there is something beaconing out based upon the event log, go find it. And you'll utilize your PowerShell snafu, find it, and then submit it to the game server. Also, from a red team perspective, we may tell you that the person's using some vulnerable version of a particular software. Utilize PowerShell to query the system to understand if it's there, when's the last time it's used, or time stop it, or whatever the case. Now, one of the other core differences between the two is that Under the Wire is linear in nature. PoSh is nonlinear, so you can skip your way around and do any question of your choosing at any time. All right, again, this is another free resource that's out there. So at this point, I am like literally 2 minutes before finishing my time. So I won't take questions here. I'll move over to Discord and I'll hang out there. I'll be there all day because I'll be partaking in the other talks that are going on as well. This presentation in about 10 minutes will be up at that link. So if you want to go download that. Also, if you're interested in any of the code I talked about or just any of my code period, there's my GitHub. And if you want to connect and you want to have conversations about this where maybe I can learn something from you and you learn something from me, again, iron sharpens iron, that's where I'm at on the Twitters. So again, I appreciate BSidesGVL for putting this on. Amazing event. I also appreciate each and every one of you for taking the time to listen to what I had to say, and I hope to interact with you on another platform. Thanks.